folks. I've been asked by one of my students to solve a problem involving surds and fractions that gives us a radical expression that we need to simplify. So all of that in the one question. Let's have a look. This is exercise 2F, I believe, in the Cambridge Year 10 textbook, or it might be 2E. Question 7, 2E, question 7F. So we're asked to simplify 5 root 12 over 3 root 27. Okay, so we need to remember some of the rules that we've learnt about multiplying and dividing surds. And that's that whenever we're multiplying or dividing surds, the coefficients in front are being multiplied or divided. In this case, it's divided. And then the expressions underneath the radicals are being multiplied or divided. In this case, it's divided. So this means that I've got 5 over 3 multiplied by the root of 12 over 27. So I separate them out, okay? The coefficients are being divided on their own, and the parts underneath the radical are being divided on their own. So let's have a look at this guy over here. Well, I've got a fraction. I want to simplify my fraction. 5 over 3 I can't simplify. There are no common factors in 5 and 3. What about 12 and 27? Do they have any common factors? Yep. 3 goes into both 12 and 27. So 12 is 3 times 4, and 27 is 3 times 9. Righto? So 3 times 4 is 12, 3 times 9 is 27. Now these 3's are, well, I've got a 3 up the top being divided by a 3 on the bottom. They cancel each other out. So I'm left with the square root of 4 over 9. Now remember, exactly the same way that we had these two surds that we combined into one surd over here, well, I can get this one surd and I can turn it into two surds, right? So this is 5 root 4 over 3 root 9. Now something interesting about the square root of 4, we know what the square root of 4 is. We get an exact value for the square root of 4. Same deal for the square root of 9. We know exactly what that is. So the square root of 4 is 2. So on in my numerator, I've got 5 times 2. And the square root of 9 is 3. So in my denominator, I've got 3 times 3. So I've got 10 over 9. And you can change that to 1 if you wanted to 1 and 1/9. Okay. So I hope that helps. Now let me just do a little bit on simplifying radical expressions just on its own, so not sort of buried in such a complicated problem where we're multiplying and dividing things and factorizing and cancelling. Let's just look at simplifying a radical expression just to cement the idea that we saw here from the root 12 down to the root 4, or from the root 27 down to the root 9. So I'm just going to look at an example that focuses in on that particular thing. Okay. So this is a thing that we did cover in class before circumstances sort of had us apart. Not that you're ever really apart on YouTube, are you? I mean, come on. So let's have a look at, say I gave you the square root of 72. Now, every single time you're working with surds, as soon as you see this radical expression, this square root expression, you should be starting to think to yourself, square numbers, square numbers, square numbers, square numbers, square numbers, square numbers. It should be like this little mantra that just sort of chirps away in the back of your mind there, okay? So what are the square numbers? Well, remember we spoke about them. We don't bother with 1 because it's a trivial case and doesn't actually help us. So we start with 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and it goes on and on and on and on and on, okay? The square numbers never end, obviously. So what I want to do with these square numbers, whenever I see an expression like this, or even if there was, whether or not there was a number in front, I don't care. Whenever I see the surd sign with a number under it, I'm thinking to myself, square numbers. Is there a square number? Is there one of these numbers here that goes into 72? Now, ideally, I want to find the biggest square number that goes into 72. Okay, so I might look and think, if 4 goes into 72, 4 goes into 72 18 times, right? Or I might look and go 9. Yep, 9 goes into 72 8 times. So there's 2 square numbers that go into 72. But I want to find the biggest square number. Sorry, pardon my phone chirping away in the background there. I want to find the biggest square number that goes into 72. Okay. So I mean, you're free to, you can use your calculator. Don't panic if if the mental arithmetic basically sort of frightens you. Don't be frightened. You can use your calculator. The biggest square number that goes into 72 is 36. So I've got the biggest square number that goes into the number under my square root sign. What do I do now? Well, now I write this 72 as a product of that 36 and however many times it goes in. So 36 times 2 is 72. Okay, so what have I done? I had this radical sign with a number underneath. I found the biggest square number I could that would go into this number, and then I wrote this as a product of that square number and whatever other factor it needed to get up to 72. Okay. And then what do I do? Well, now I separate this this product out into 2 different surds. That's the square root of 36 times the square root of 2. And the square root of 36 I know. Okay, square root of 36 is 6. So that's just 6 root 2. Okay, I've simplified that radical expression. Now, you just need to be able to have the confidence to do that, even if the square root of 72 turned up in a problem in some other context. So I might have a problem that had, 7 root 5, forgive me, 7 root 5 plus 8 root 72, sorry, look at that. 8 root 72 over 3 root 11. I just need to not panic when I see questions like this and just go through one at a time. Can I simplify the root 5? No square numbers going to it. Don't worry about it. Can I simplify the root 72? Yeah, I can. So I just go through the same process, just with that root 72 there. So I'd end up with 8 times 6 root 2. That'd be 48 root 2. Okay. But anyway, look, I'll leave you to go back and go over some of those questions on simplifying radical expressions that were earlier in chapter 2. And if there's still any problems, let me know. Anyway, I hope that answers question 7F properly for you. And then if there's anything more I can do, question and comments below or question over in Microsoft Teams. Thanks, guys.